Palindromes are words that are the same backwards and forwards. Some of the toughest string interview questions revolve around palindromes. Using the skills we've learned, we'll see a few different ways to validate one and make sure it fits all conditions. This is AlgoDaily. In tackling the validate palindrome problem, it's really important that we understand properly what is a palindrome and what isn't a palindrome. So we have a few examples here. The first one, toot, T-O-O-T, is a string. It's clearly a palindrome because it reads the same front to back. So front to back, it's toot, as well as back to front. Back to front is also toot. So we know this is a palindrome. Boot is not a palindrome because it's from front to back, it's boot, but from back to front, it's tube. So boot does not equal tube, and we know that that's not a palindrome. And this should give you a little bit of a hint for the brute force method that we're going to try in a bit. And then this final example is also a palindrome. So one of the cases that we have to handle is white space and special characters and casing, like in this sentence. And if you read this from front to back, it clearly says a Santa lived as a devil at NASA. But if you read it from back to front, it actually is the same string with a little bit of extra characters and some spacing, but it does read a Santa lived as a devil at NASA. What we have in front of us is an infographic that'll help us anticipate and understand the brute force solution for finding if a string is a palindrome or not. So we have the input A, B, C, C, B, A, and this is obviously a palindrome. We can visually scan from left to right and from right to left, and it's definitely the same forwards as well as backwards. In the second input, we have A, B, C. It's A, B, C forwards, but C, B, A backwards, and so it's not a palindrome. What you'll notice in this example is that the two sides are flipped. So they're kind of inverses of each other. If we were to take this part and compare it with this part, then it would be the same string. An easy way to take that approach and apply it to a programmatic sense is to just flip the entire thing around. So if we have a palindrome, A, B, C, C, B, A, and we reverse it the same way we reverse a string, the reversed string would be A, B, C, C, B, A. And so we could just compare the string with its reversed version, and we should end up with the same thing if it is a palindrome. On this lower left box, we can see how to do it programmatically using JavaScript. So we have the string, we would split it, and we would get an array at this point of letters as elements. We would reverse it. In this case, if we reverse the first string or the first array of string elements, we would end up with just the same thing back, and then we would join it. If the reversed is the same as the string, then we know it's true. Otherwise, of course, it's not a palindrome. Okay, cool. So now that we have a sense of how the brute force solution for a validate palindrome is going to work, let's look at the code for it. In my opinion, it's rather simple. We take an input string and we essentially just reverse it. So we'll take the string and we'll apply it to this chain of methods. So we'll split it, becomes an array. We'll reverse the array using the built-in reverse method, and then we'll join it back and it becomes a string again. And then we compare the original string with the reverse string. If it returns true, it's true. and it is a palindrome. Otherwise, it is not a palindrome. Now that we know the brute force way to solve the problem, let's think of a more efficient way. Let's say we don't have access to a reverse method. What can we do? Well, lucky for us, we've tackled reversing a string before without using the built-in reverse method. And we know, as you can see from this diagram, that we can use 2 pointers. So if you think about the way we use 2 pointers to reverse a string, it shouldn't be too difficult to figure out how we might use 2 pointers to validate a palindrome. We've already discussed how a palindrome is essentially the same string from front to back and from back to front. But that also means that if you cut the string in half and we just had TO and OT, they'll be inverses of each other. So as you can probably imagine, we can make use of 2 pointers by checking the first with the last, seeing if they're the same, in this case they are, and then just moving them in. And in this case, O and O are the same, so we know it's a valid palindrome. And the same thing happens here. We won't go through this entire example, but starting at A, we see they're the same. We can move, and we'll have to write some code to handle the spacing, but that should be relatively trivial because there's ways to normalize the strings. But then we see S is the same, and we see A is the same, we see N is the same, and so on. Here's the final code for a more efficient way to find out if a string is a palindrome or not. And we're going to go through this, but I just want to highlight this added helper here. So this is what's going to help us test if the character that we're operating on is alphanumeric or not. We only care about the alphanumeric characters, and this will be sure to exclude spaces and special characters that we might not care about. Like, let's say there was an exclamation point, and it would also handle all the spaces. So we take the input string, we check if it's an empty string. If it is, an empty string is a palindrome, so we let it go. Otherwise, we start off with our 2 pointers. We have a left pointer and a right pointer. But then we also have a left character and a right character, and we'll shortly see what they do. So while the left pointer is less than the right pointer, while we can continue to move inwards from the string, from the ends of the string rather, we set the left character to the string character at that pointer, and we lowercase it. Same with the right character. Racecar equals string at the right pointer, and we lowercase it. And so what we've done here is we've extracted the strings, or we've extracted the characters at either end, and then we've normalized it by lowercasing it. Then we check if it's alphanumeric, and we also check if the racecar is alphanumeric. And if they are both alphanumeric, then we know that we can validly compare them against each other. If they're not alphanumeric, then what we want to do is we want to increment the left pointer or the right pointer, depending on which one we're on. And it's because, let's say we're here and we're about to compare the space with the S, this space here with this S. Well, that doesn't make a whole lot of sense. So we want to actually increment 1 and then compare this S with this S. And so we'll keep moving inwards until we get to the very end. And if we can reach this true statement, this return statement at all, then we know that we've done a good job at getting past all of the characters and making sure that they're equal on both sides and that this string is a palindrome.